Hello everyone, welcome to this session. Our topic is thermocurrent electricity. So far in our previous video, we discussed the mechanism of heating through the current electricity. So today let's discuss about the electrical power. Now we'll start with the concept of electrical power. Electrical power, this is just the electrical energy delivered per unit time taken to deliver such kind of energy. Now, mathematically, you can say that power equals to the electrical energy per time taken, uh, whereby this I square RT is just the formula we saw in our previous video when we were discussing the mechanism of heating through the current electricity. So electrical energy equals to current squared multiplied by resistance multiplied by time. Now, from there, this time that is dividing the electrical energy, that is I square RT upon the time, that is T, will be cancelled out. So this T and the upper T will be cancelled out together. So we will remain with power equals to I square R. So this is what is remaining. Now, this, you know that if you extend that I square R will just be equal to power equals to IR multiplied by I. You can return it by multiplying this I inside to this bracket, you get I square R. Now, IR is just voltage. So from the Ohm's law, voltage is equal to IR. So simply power will be equal to voltage multiplied by current. So this is our formula. Power is equal to IV, that is current multiplied by the voltage. I hope it's clear. Now, every electrical appliance should carry simply a label stating or just starting with the potential difference for which it is designed and the power it can convert when operating at a stated potential difference. So all electrical appliances just carry this kind of labeling to enable a person to understand exactly the potential difference which is there and the power that can be converted when operating at a given such potential difference. Now let's see an example according to the formula which we've seen before, that is power is equal to voltage times current. Now example, calculate A, the current taken, and B, the resistance of the plate of electric iron related 240 volts and 2000 watts. Now we'll start with the first one, calculating the current. Now, since you have to know that we said that power is equal to IV, that is current times voltage. Now here we're looking for the current. So simply you make current or just I the subject. So you divide it by V both sides. So it will remain I is equal to P upon V. Now we substitute the values, whereby the value of the power is 200 watts, 2000 watts, and the voltage is 240 volts. So if you substitute the values, so will be equal to I is equal to 2000 watts, you divide by the 240 volts. Then our answer you get, that is I current is equal to 8.33 ampere. Simple like that. So the current electricity I is equal to 8.33 ampere. Moving on to the B, that is, we have to calculate the resistance of the plate of the electrical iron. Now, since also power, we said that is equal to IV, but also power is equal to V square R. And you can derive this from the general formula, that is power is equal to IV. So from here, we are trying to determine the resistance. So we've derived to a point that power is equal to V square upon R. Now you make R the subject, so you multiply by R both sides, and you get that R is equal to V square upon the P, that is the power. So just substitute the values, you get that the resistance is equal to 240 square divided by the 2000. So R, that is the resistance of the wire, you get 28.8 ohms. I hope it's clear. You can simply practice more and more by finding other various examples and various questions just to get to know these kinds of questions. Moving on, let's see the power rating on the electrical appliances. Now, the commercial unit of the electrical energy is the kilowatt hour, abbreviated as kWh. So the commercial unit of various electrical appliances the energy that they use, the electrical energy that they use is the kilowatt hour. Now, the kilowatt hour, this is the energy supplied in 1 hour by an appliance working at the rate of the 1,000 watts. So from there, you get that 1 kilowatt hour is equal to just 1,000 watt times 1 hour. Now, if you know that 1 hour is equal to 3,600 seconds, so you get that equals to 3.6 times 10 raised to 6 joules. So this is just basically how it is that how the kilowatt hour is the energy that is supplied given by 1 hour to the appliances at the given rate of 1,000 watts. Now, let's see an example. What is the cost of using an electric iron rated 240 volts and 2000 watts for 10 hours if the electrical energy costs Indian rupees 100 per unit? Now, we know that 1 unit is equal to 1 kilowatt hour. Now, total energy that is used for 10 hours will just be equal to 2000 watts times 10 hours. Now from there, you just know that 2000 watt hour will be equal to just 20 kilowatt hour. Now the cost of using the appliance, you get that 1 kilowatt hour is equal to 100 Indian rupees. Now 20 kilowatt hour will be equal to how much? So just make X the subject. So you get this 20 kilowatt hour, you multiply by 100 rupees, then you divide by 1 kilowatt hour. Then the value of X is 2000 Indian rupees. So the cost of using the appliance is just simply 2000 Indian rupees. So I hope it's clear, guys. Thank you for listening. Briefly, we've discussed the concept of electrical power. We've seen the general formula for the power. We've seen a worked example, and we've later on seen the electrical power related to the various appliances which we use in our daily life. We've seen the how we can find the costs within a worked example. I hope it's clear. Thank you.